Hi friends, today in this chapter we are going to discuss about unit and measurements. Before going into the subject, first we need to understand physical quantities and the things which we will consider as the physical quantities and which we are not considering as physical quantities. For example, length, mass, time and force. The things which can be measured, we can call them as a physical quantities, and not physical quantities like anger, sad, happiness, what all feelings we have, all the feelings and the things which we cannot measure them, they are considered as not physical quantities. Physical quantities are broadly classified on the basis of magnitude, like scalar quantity and vector quantity. If you see scalar quantity, it has only magnitude and there is no direction specific, whereas vector quantity has both direction and magnitude. Also, physical quantities can be classified on the basis of measurement unit, like fundamental quantities and derived quantities. Okay, further, if you see scalar quantities, we will have examples like distance, speed, mass, volume, time, etc. Before I discussed, scalar quantities has only magnitude and they are not direction specific, whereas vector quantities are both, they have magnitude as well as the direction specific, like force, displacement, velocity, momentum, etc. If you see in one question, which of the following is a scalar quantity? They have given four options: momentum, force, mass, and velocity. If you see here, force F is equals to ma. Okay, a is an acceleration, it is a vector, therefore force is also a vector. Momentum P is equals to m into v. V is a velocity, it is a vector, therefore momentum is also a vector. And here velocity is a vector. So option C, mass, is a scalar quantity. Option C is the right answer. And if you see another example, what is the example of a vector quantity? Option A, mass. Option B, temperature. Option C, velocity. And option D, length. Here velocity is a vector quantity, whereas mass, temperature, length, those all are scalar quantities. And if you see, and here we will discuss about fundamental quantities and derived quantities. Basically, quantities are broad, clear, basic quantities which we will use them for the measurement are called fundamental quantities, and these derived quantities are the quantities which are derived from the fundamental quantities. By using the fundamental quantities, we will derive the quantities, those are called derived quantities. If you see example for the fundamental quantities are like mass, length, time, temperature, electric current, luminous intensity and amount of substance. And the derived quantities examples are force, velocity, density, heat, power, energy, pressure, acceleration. And here mass is a fundamental quantity and mass is measured in kgs. Okay, and length is measured in meter, time is measured in second, temperature is measured in Kelvin, electric current is measured in ampere, luminous intensity is measured in candela, amount of substance is measured in mole. Okay, only these seven are considered as a fundamental quantities, and other quantities other than the seven quantities we will consider them as a derived quantities. Okay, if you go in deeper, if you see few examples, in this question you can find that which of the following is not a fundamental quantity. Before I have told the seven fundamental quantities. Mass is a fundamental, temperature is also a fundamental, length is a fundamental, whereas speed is not fundamental quantity. So option C is the right answer. If you see the next question, which of the following statement is or correct? The mass of an object is same as its weight. No, that is wrong. Mass is constant everywhere, whereas weight will change. Here, if you consider, and if mass of an object is same, either it is in earth or on its moon, whereas weight will differ. Weight, weight here, gravitational force will come into picture if you talk about weight. Therefore, mass is same, whereas weight is not same. So, first statement is false. Second statement, the mass of an object is not the same as its weight. Yes, it is true. Third statement, mass is a scalar quantity. Yes. whereas weight is a vector quantity. Yes, this is also a true, because weight is having, always weight has a downward pull, that is gravitational force. So weight is having a direction, that is acting downwards. So mass is a scalar and weight is a vector, that is true. So option 2 and 3 statements are true. Here if you see in option D, statement 2 and 3 are true. So option D is the right answer. And here every measured quantity is comprises of a number and a unit. Okay, here in this example if you see 3000 seconds, this 3600 seconds, 3600, this number it is called the, this magnitude is called the number, and followed by second, that second is the unit. And another example 127 centimeter, here 127 is the number and centimeter is the unit. Similarly 6 foot, 6 is the number, that foot is the unit. Also if you see different types of systems of units, okay, we will have broadly four system of units. One is fps, and second cgs, third mks, and fourth si. If you see first system, that is fps, foot pound second system, it is also called as British system of units. Here weight is measured in foot, length is measured in, weight is measured in pounds, length is measured in foot, time is measured in seconds. 1 pound means approximate half kg. Okay, around 4.53 kg. It is also called as 453 grams, 1 pound means. And another system is CGS. It is centimeter gram second system. It is also called as Gaussian system of units. And it is also called as a French system or metric system. And the third one here is MKS, meter kilogram second system. Here in the length is measured in meter, weight is measured in kilogram, and time is measured in seconds. And these three systems are independently followed. In some countries they follow CGS, in some countries they follow MKS. Whereas the final fourth system, SI, international system, it is followed international level. Okay, if two countries are being involved in any transaction, they will follow this international system of units, which is similar to both countries. This international system of units is introduced in 1971 by international agreement. 7 physical quantities have been chosen as fundamental or base physical quantities, and 2 are chosen as supplementary quantities. If you see in CGS, length is measured in centimeter, mass is measured in gram, time is measured in second. In FPS, foot pound second, MKS, meter kilogram second. And here SI is the international system which is brought for the easy communication between all the countries around the world. So this international system, they have introduced 7 basic fundamental quantities. For mass they have chosen fundamental unit as kilogram and the symbol is kg. And for length they have chosen fundamental unit meter, and for time they have chosen second, temperature they have chosen Kelvin, electric current ampere, luminous intensity candela, amount of substance is mole. Okay, these are the 7 fundamental quantities. And also by with the help of these fundamental quantities we can derive few quantities, and those quantities are called as derived quantities. Like example, area is measured in meter square, volume meter cube, density kg per meter cube, speed meter per second, velocity meter per second, acceleration meter per second square. Okay, and force F is equals to MA, kg meter per second square. Force unit is Newton. Kg meter per second square is also is equals to 1 Newton. Momentum P is equals to M into V, kg meter per second. Impulse, force into time. Small impulse is nothing but amount of force applied per fraction of second. So Newton second is a unit for impulse. Pressure, Newton per meter square. Unit of pressure is Pascal. Work means unit of work is joule. Force into distance. Newton meter is also a unit of work. It is nothing but 1 joule. Power is equals to rate of doing work, that is joule per second. Joule per second is also called as watt. Unit of power is watt. And not only these 7 fundamental quantities, 2 more fundamental quantities were introduced by International System of Units. Those 2 extra fundamental quantities are called as supplementary fundamental quantities or supplementary physical quantities. Those are plane angle and solid angle. Plane angle is unit is radian, solid angle is steradian. Okay, radian is in two dimensional. To measure the angle between the to measure the angle they use this radian. In that is 2D. If you see in 3D, they will consider that as a steradian. Other units of length, uh, 1 yard. 1 yard is nothing but 3 feet. 3 feet means 36 inch. 1 foot. 1 foot means 1 yard means 3 foot, that is 36 inch. 1 foot means 12 inch. 1 inch means 2.54 centimeter. And for measuring larger distance also there are units. Those are very important, like astronomical unit. Astronomical unit is nothing but it is an average distance of the center of the sun to the center of the earth. Okay, that is nothing but distance between the sun and the earth. We will call it as an astronomical unit. It is a unit of distance. One astronomical unit is nothing but approximately 1.5 into 10 to the power of 11 meters. And also there are another larger units for distance measuring. Those are light year. Light year is also is nothing but distance traveled by the light in vacuum in 1 year. Okay, 1 light year is nothing but 9.46 into 10 to the power of 15 meters. More than astronomical, light year is a bigger unit. Okay, and also parsec. Parsec is the distance of the celestial body from the earth when that body is at a divergent angle of 1 arc second. Okay, if you see in the form of magnitude, parsec is the highest unit of distance, after that light year, and after that astronomic unit. Okay, 1 parsec is nothing but 3.1 into 10 to the power of 16 meters. 1 parsec is 3.2 light years. 1 parsec is 206,265 astronomical units. So in magnitude wise, parsec is the largest one, after that light year, after that astronomical unit. And to represent, if you see few questions on these things. First question, to represent some quantities, their duration is also specified along with their magnitude. This type of physical quantity is called vector. Okay, if you they for vector we need magnitude as well as direction. So option A, vector, is the right answer. Next question, which of the following is a symbol for mole in SI system? That is small mol. Okay, option B is the right answer. And the next question, which of the following is the SI unit of temperature? Obviously Kelvin. So option D, Kelvin, is the right answer. And the next question is, the length of the approximate distance from the earth to the sun is called 1 astronomical unit. Option B is the right answer. And next question, what is measured by light year? Light year is a unit of distance. So option B, distance, is the right answer. And next question, 1 astronomical unit is a distance equivalent to how much? 1 astronomical unit is nothing but 1.5 into 10 to the power of 11 meters. That is given in option B. And the next question, 1 yard in SI unit is equals to, 1 yard is nothing but less than 1 meter. So option A, 0.9144 meter, is the right answer. 1 yard means 36 inches. 36, 1 inch means 2.54 centimeter. If you see 91.44 centimeter, approximately less than a meter, 0.9 meter. And this 1 yard is nothing but 1 yard means approximately 0.9 meter. And another also, there are few other practical units which we need to remember. Some important practical units are, for if you see for small distances, 1 micron is nothing but 10 to the power of minus 6 meter. And 1 angstrom means 10 to the power of minus 10 meter. And 1 Fermi means 10 to the power of minus 15 meter. Also for heavy masses, 1 ton. 1 ton is nothing but 1000 kg. 1 quintal means 100 kg. Also for volume, 1 meter cube is nothing but 1000 liters, and 1 barrel means 159 liter. 1 US gallon means 3.7 liter. 1 UK gallon means 4.5 liters. And if you see few questions, 1 gallon is commonly used for, it is used for as a measure of volume. So option C as a measure of volume is a right answer. 1 gallon means approximately 3.7 liters. 1 micron means how many centimeter? 1 micron means 10 to the power of minus 6 meter, and if you convert it as a centimeter, 10 power of minus 6 into 10 square centimeter, that is 10 to the power of minus 4 centimeter. Option B 0.0001 is the right answer. Here SI prefixes are given which you need to remember, like kilo means 10 power of 3, hecto means 10 square, deca means 10, deci means 10 to the power of minus 1, centi means 10 to the power of minus 2, hexa means 10 to the power of 18, peta means 10 to the power of 15, tera means 10 to the power of 12, giga means 10 to the power of 9, mega means 10 to the power of 6, milli means 10 to the power of minus 3, micro means 10 to the power of minus 6, nano means 10 to the power of minus 9, pico is 10 to the power of minus 12, femto or fermi means 10 to the power of minus 15. Okay, directly they will not ask, but in few problems they will tell as megapascal. Then you need to know that megapascal is nothing but 10 to the power of 6 pascals. And in few examples they may tell us 10 nanometer, that means 10 into 10 to the power of minus 9 meter, like that. Nano means 10 to the power of 9. Okay, like this prefixes you need to remember. And here if you see in these examples, here 4 kilometer, kilo means 1000 meter, therefore 4 into 1000, 4000 meter. 3 hm, the small h means hecto, 3 hectometer, hecto means 10 square, 3 into 10 square meter, that is 300 meters. If you see here 8 DAS they have given, here 8 DA means deca means 10, so 8 into deca means 10, 8 into 10 second, that is 80 seconds. Similarly 80 centimeter, centimeter means 10 to the power of minus 2 meter, so 0.8 meter. For capital EN, here capital E is nothing but hexa means 10 to the power of 18, 4 into 10 to the power of 18 Newton. Okay, so here in these prefixes you need to remember, then only you can solve this kind of small things in problems. And here if you see here 2 capital PM, here capital P is nothing but peta. Peta means 10 to the power of 15, so 2 PM is equals to 2 into 10 to the power of 15 meter. Similarly 8 GPA, G means gigapascal, giga, PA means pascal, giga means 10 to the power of 9, so 8 into 10 to the power of 9 pascals. And 8000 ml, ml means m means milliliter, milli means 10 to the power of minus 3 liter, so 8000 into 10 to the power of minus 3, 8 liter. 600 micrometer, micro means 10 to the power of minus 6 meter, 10 into 6 into 10 to the power of minus 4 meter. 800 nanometer, nano means 10 to the power of minus 9. Similarly 4 small pm, small p is nothing but pico, pico means 10 to the power of minus 12, 4 into 10 to the power of minus 12 meters. Okay, here we will discuss on some instruments which are used in measuring the quantities, for example if you see altimeter. Okay, these are only few, there are many instruments which we cannot remember everything, so only important some 10 to 15 instruments we will discuss here, and that instrument name and what that instrument will measure. Okay, the only those two things we need to remember. First one is altimeter. Altimeter means altitude means height. Okay, altimeter means this instrument will measure altitude. This is used in aircrafts. Okay, altimeter is used in it will measure the altitude and it is used in aircrafts. Ammeter is this ammeter is used to measure the electric current. Okay, and barometer is used to measure the atmospheric pressure. Anemometer. Anemometer will measures the wind speed. Generally near the uh, oceans, they will use this anemometer to uh, find the wind speed. And fathometer. This fathometer will measure the depth of ocean. And galvanometer. Galvanometer also measures electric current. Here if you see, ammeter is also measuring electric current, galvanometer is also measuring electric current, whereas ammeter will measures electric current and galvanometer measures small electric current. Small amount of electric current is measured with galvanometer. Okay. Hydrometer will measures relative density of liquids. Hygrometer, it will measure the level of humidity, how much water vapor is present in air, that is called the humidity. Okay, that level of humidity will be measured by the hygrometer. Okay, and if you see here, hydrometer, it will measure relative density of liquids. Relative density is nothing but it is the density of the fluid divided by density of standard fluid. Generally, for liquids, we will consider water as a standard fluid, and for gases, we will consider air as a standard fluid. And the standard fluid density for density of water is 1000 kg per meter cube, and density of air is 1.2 kg per meter cube. Here you can see relative density of mercury. Relative density is nothing but density of the mercury divided by density of the standard fluid. Density of the mercury is 13,600 divided by 1000 is equals to 13.6. So relative density of mercury is 13.6. And manometer, it is a device. Manometer will measures pressures of gases and liquids. And microscope is an instrument used to magnify the view of small objects. And this sphygmometer, it will measure the blood pressure. And stethoscope will analyze heart sound. Also some, here we will discuss few instruments like tachometer, it will measure rotational speed of the shaft. Calorimeter, it will measure the heat content. Lactometer will measure the purity of milk. Viscometer will measure the viscosity of liquid. And here in this diagram you can see this is called periscope. Periscope, it is used in submarine to see the objects. Okay, here I symbol is there now. This is here uh, is submarine generally it will be inside the water, and using this instrument name is periscope. With this Z type instrument, with by using this instrument they will see the object. Okay, whoever is coming, it might be enemies or another ships. So they will here they will use two mirrors in this periscope. Two mirrors will be there. With the help of these two mirrors and with a device called periscope, they will identify the person coming nearer to them. Okay, generally in submarines they will use that. And also helioscope is an instrument used to view the sun. Okay, helio means sun, helioscope to view sun. And polygraph is an instrument, generally it is used by the police department. It is also called as a lie detector. Okay. Pyrometer, pyro means high temperature. Pyrometer is a device that is used to measure high temperatures. This is a non-contact device that measures high temperatures. If you see one question, odometer is a device used to measure dash in vehicles. In vehicles, odometer is a device that is used to measure the distance traveled. Okay, how many kilometers that bike has traveled, that is measured by seeing that odometer. Okay, epidiascope, it is a projector that displays both opaque objects and transparent ones by reflecting or transmitting light onto a screen. Also, if you see the next question, what is measured by hygrometer? Hygrometer is measured, humidity will be measured by hygrometer. Option B, humidity is the right answer. And next one, which of the following instrument is used to measure atmospheric pressure? Obviously barometer. So option D, barometer is the right answer. Next question, which instrument is used in submarines to see objects above sea level? That is periscope. Option C is the right answer. Next question, which instrument is used to observe the sun? Helioscope. Here in option C they have given helioscope. That is the right answer. And one more question, which of the following is a lie detector machine? That is polygraph. Here in option C they have given polygraph is a lie detector machine. Also these here we have discussed about few machines, okay, or instruments, and the quantity they are going to measure. And also we will discuss dimensional formula also. You need to remember, dimensional formula is nothing but every quantity, broadly it will have only three, that is mass, length and time. Okay, if you see area, that is L square. If you want, the dimensional formula of area is L square. Similarly volume is meter cube, so meter is nothing but length, so L cube. Density means kg per meter cube, kg means mass, m divided by meter cube, so L3, m by L3, it can also be written as m into L power of minus 3. Similarly speed means meter per second. Here meter means it is a unit of length, so L. Meter per second, second means time, t, so L by t. L by t can also be written as L into t power minus 1. Okay, this is the end of this chapter, units and measurement. Hope you like this video. Thank you. Thanks for watching.